Okay guys, happy Friday, good morning, here we go. So today we have the hyperbola to look at, and why don't we begin with the model of the hyperbola. So why don't we go right here, and let's see if we can draw this. So for a hyperbola, here is what your hyperbolas will look like. Actually, you know what, why don't you go pencils down, and I'll show you on Desmos real quick here. So yesterday, in class, we discussed the ellipse. We spent the whole day talking about the ellipse, which has this equation and this feature. So I'm going to make one change. You see this addition? Instead of a sum, I'm going to erase that guy, and I'm going to turn it into a subtraction with a minus. And by doing that one small change, going from addition to subtraction, we go from an ellipse into suddenly a hyperbola. And a hyperbola looks like two parabolas sort of back to back. You see that? So this is what a hyperbola can look like. It can possibly look like this, kind of sideways, or a hyperbola could possibly look sort of the vertical variety. You see that? So hyperbolas, they can be like sideways or they can be up down. So be prepared for two cases. And here are the equations for both cases. So let's say that your hyperbola was sort of the sideways variety. And actually, let me draw this big because we're going to label A's, B's, and C's and stuff. So let's draw this kind of big actually. So go like big sideways like this here, watch. Go like that there. Go like that here. And let me draw this one a little bit separated actually, more like this here. There we go. And so here what we're going to have in between, that is going to be what we call the center. And this point here and this point here, this is a vertex. That is also a vertex. And then what we're going to have is we are going to have our foci. One of them is sort of going to be like right there, and the other one is sort of going to be like right here somewhere, okay? So we're going to have a vertex, and we're going to have a focus and a focus. So that's a vertex there, and this is a focus here. So we have two vertices, and we have two foci, all right? Now, I do want to tell you like A's, B's, and C's, yes? So from your center to a vertex, that distance we still call A. From your center to your focus, that distance we call C. Now, there is going to be here in blue, you guys are going to see that we have sort of a box, a rectangular dotted box. So draw a box like this, if you would. Draw like a rectangle there. And then what I want you to do is draw the diagonals of this rectangle. Draw the diagonals of this rectangle like this. Right? Sort of like a dotted line. Not the best picture, but what we're going to have is we're going to have a box, a rectangle in the middle. And we're going to have diagonals. And these diagonals, they sort of serve as asymptotes for the hyperbola. You'll see in just a moment. And the reason I draw this box is to show you what the value of B is. So I told you what A is. We looked at C. Now the value of B is going to be this. From your center, go either straight up or straight down. And that there, that would be the value of B. Okay, so we have A, B, and C, where A is from the center to a vertex. B is from the center to one of the sides of your rectangular box, right, of your box. And then C goes from center all the way to your focus. And I do want to say that the name of this dotted rectangle, we can call that, some books call it the central rectangle. Okay, some books call it the central rectangle. So And this is the sideways version. Now let me give you the equation, right? I have to tell you the equation for this guy. And your equation would look like this. So let me erase the word central rectangle. And let me tell you the equation for the hyperbola itself. All right? So it would look like this. The one that goes sideways, it would go like x minus h squared over a squared minus y minus k squared over b squared always equals 1. Always equals 1. Where, of course, h and k, right? Let's not take this for granted. H and k, those are the coordinates of the center, h and k. The center is at h comma k. And now what I want you guys to do is I want you to draw the other case of the hyperbola, the one where instead of going side to side, it opens up and down. For this one here, for that one. And the equation there, it would begin with y's this time. Y minus k squared over a squared minus x minus h squared over b squared equals 1. While you guys are copying, I'll get my graph paper ready. There's my graph paper right here. Hopefully you guys, it grabs well on the camera because there's a little bit of a glare, but there it is. Let me move this a little bit to the left. Okay, so why don't we begin by identifying the center. Where would be the center of this hyperbola? So I'm going to say center would be at 3, -1, right? Positive 3, -1. Always go to the x's, then go to the y's. And switch the numbers. H and k, 3, -1. And let's go to 1, 2, 3, -1, and put a point right there. Okay? Now, I recommend that up next, you draw your central rectangle. So, this is a squared. This tells you that a is 7. This is b squared. This tells you that b is 5. I'm going to call this center, so I don't forget. That's my center. Now, this 7 here, we're going to have to go for a walk. 7 spaces, but is that going to be side to side or up and down? Well, this 7 is associated with y. Y is up and down. So from your center, we have to go up and down 7 spaces. So 1, 2, 3, 4, 5, 6, 7. Put a dot there. And then go down 7. 1, 2, 3, 4, 5, 6, 7. Perfect, like right there. And now let's go for a walk. 5 spaces left and right because it's attached to x and x is horizontal. So let's see. 1, 2, 3, 4, 5. Más o menos ahí. 1, 2, 3, 4, 5. Like right there. And so what you do with these 4 points is you connect them with a dotted rectangle. And let me try this with a different marker because this blue is finished. So let's go up like this. Much better. Draw a central rectangle. Okay. And then once you have your rectangle, what you really want to do is draw your diagonals in dotted form. So let me use green. So draw your diagonals from one corner to the opposite corner, passing through the center. And you actually want to draw them big. Draw them well beyond the rectangle. So they go on forever and ever and ever. And now, all we have to do now, guys, is draw the actual hyperbola itself. So ask yourself, this hyperbola, is it the up and down or the sideways variety? Well, the letter y appears first, so I know that my hyperbola should be like up and down. So what you do is go to the top and bottom points, this guy here and this one here. And then draw like this. Draw sort of a parabola inside of the green diagonals and do the same down here. And guess what, folks? We're done. We're finished. That's all you have to do if you want to graph the hyperbola. If you want, maybe we could give them the foci because they might ask for that on your solo quiz. So let's find the foci, and then I'll give you some more info about this because there's a couple more things I want to say. So now for the foci, we need C. And we also know that for the hyperbola, if I go back to the previous page for the hyperbola model, I should have also told you guys this. There's a bonus equation, okay? So for the hyperbola, it is also true, so jot this down, really important. It is also true for the hyperbola that a squared plus b squared equals c squared. I know for the ellipse it was minus, but no, for the hyperbola, it's a squared plus b squared equals c squared, like the Pythagorean theorem, okay? So that's also true. A squared plus b squared equals c squared for the hyperbola. And so as we were over here. So now we can find c. So we know that a squared plus b squared equals c squared. So we have a squared, and we have b squared, and this is going to equal c squared. And what is this, like 74? And so c equals the square root of 74. And gosh, what's the square root of 74? I mean, I have no idea. Let's go to Desmos. So let's see, 74 to the power of 0.5 is about 8.6, okay? So it's about 8.6. So this guy here, this is about 8.6. And so from your center, go up and down about 8.6 spaces. So this was up 7, so this is 8.6. This is like right there. And this was like down here. And so this is going to be my focus, and this is going to be my focus. And the actual coordinates of the foci, our foci, would be located here. They would be located at wherever the center is. But from the center, from the y-coordinate, of the center, we have to go up and down the square root of 74. So for that reason, I'm going to go plus or minus the square root of 74. So this is a very common way to answer your foci. Instead of two separate ordered pairs, combine them into one by just going plus or minus. So we have the graph there, we have the center, we have, now here's another question. The ellipse had 4 vertices, 2 majors, 2 minors, right? 4 of them. The hyperbola, nuh-uh. The hyperbola has only 2 vertices, period. It doesn't have 2 majors and 2 minors. No. It has 2 vertices, end of story. And that would be these guys, right? This is a vertex. This is a vertex. I'm not even going to say major vertex, because if I say major, that implies that there are minor. But this doesn't have minor vertices. It has a vertex, another vertex, that's it. This guy here, this is not a vertex, because this is not on the hyperbola, right? It's part of the central rectangle, which helps us to draw the hyperbola. So let's begin by identifying the center. Where is our center? Our center is at, well, let's see. Our center is at -2, 5, right? That's my center. Now, I know here that A is going to be 6, and that B is going to be 2, right? Just square root them. So we have 6 and 2. Now, this 6, because it goes with x's, it's going to be side to side. So from your center, go 6 spaces one way, and then 6 spaces the other. There we go. And then go up and down 2 spaces. Up and down 2 spaces. And use all 4 points to draw a dotted rectangle. Okay. And then draw your diagonals really big through the center and the corner of your rectangle, and the other one as well. They're not too bad there. Now, my hyperbola is which kind? Because the x's appear first, we know it's the horizontal variety, so they're going to be sideways. So the hyperbola here in orange, right, it's going to be like this. It goes through this point here, like that there. It goes through that one, and it goes through this one here. And maybe we could give them the vertices. Right? I think in the previous exercise, we didn't clearly identify the vertices, although we drew them. Wouldn't be a bad idea just to give you the coordinates of them. So this is going to be like at, like -8 it looks like. 1, 2, 3, 4, 5, 6, 7, 8. -8, comma, 5. And then this one's going to be at, what would that be, like 4? 1, 2, 3, 4, comma, 5. Yeah. So my vertices are there. Let's draw the foci. Let's find C. So we know that a squared plus b squared equals c squared. And we know that this is a squared and this is b squared. So 36 plus 4 is 40. And then you square root. So we know that c is going to be the square root of 40. And gosh darn it, what is the square root of 40? Let's go back over here. Let's turn this into the square root of 40. About 6.3, okay? About 6.3. So from your center, go 1, 2, 3, 4, 5, 6.3 spaces each ways. And that's going to be, those are going to be your foci, right? Those are going to be your foci. And what would be the coordinates of your foci? Well, we go to our x coordinate of the center, -2. And then you'd go left and right this much. So it looks like it would be -2 plus or minus. And in the foci, both have a y coordinate of exactly, it looks like 5 spaces. And I also want to say before you guys go that these green diagonals, really what they actually are is these guys are the asymptotes, right? They're the asymptotes that we draw because they help us to draw within the lines, right? They give shape to the actual hyperbola itself. So again, in summary, a hyperbola has a central rectangle, 2 asymptotes, 2 vertices, it has 2 foci, it has the eccentricity. We didn't do any problem with that one, but the eccentricity, you should jot this down, the eccentricity, like the ellipse, it's also C over A. So you can expect on Tuesday that after I return the team tests, maybe we'll do a couple more problems with hyperbolas, like writing equations, which we didn't do today. We'll do that on Tuesday, and then we can do the solo quiz. But for now, try to catch up with the homework so that you're all caught up, okay? So if you have any questions, you can just let me know. If not, have a great weekend, a long weekend, and I'll see you guys on Tuesday. Bye.